about 2:02 though, and I think we should get started with this. So we're going to start right now. Again, everyone, my name is Alan Schimmel, and I am the editor-in-chief of DevOps.com. We are very happy to have a great webinar today on scaling web applications with NGINX load balancing and caching. Our presenters today are Matt Williams, evangelist with Datadog, and Rick Nelson, technical solutions architect with NGINX. As I mentioned earlier, you might have heard, there is a section of your GoToWebinar interface where you'll be able to ask questions, and we have set aside time at the conclusion of the presentation today, and we'll get to as many of your questions as possible. We will also be asking some polling questions before we begin in just a second here, and we'd appreciate your response to that to help our panelists today better gauge sort of who our audience is and where you may be along the continuum of scaling web applications, load balancing, and caching. So without further ado, I'd like to ask our first polling question, and it's how many hosts are you currently managing? And please select one. This is not a difficult question. I would hope we get a lot of votes relatively quickly. We'll keep it open for just another 5 or 6 seconds here. Okay, going once, going twice. Okay, and we are done. Polling closed, 77% voted, and the results are 10 to 100, 45% represent, I guess, the overwhelming majority, with less than 10 coming in second place. This is pretty much in line with results I've seen, where when we're talking about cloud servers and cloud instances, about 45 to 50, 75 seems to be around that normal range for a smaller company. Okay, let's go to our next polling question now. And this is really geared for those of you who may have had some experience with NGINX, or if you haven't, please tell us to. So polling is open. Again, we're going to ask you to vote. We'll just keep this up about 10 seconds. Just another 3 seconds, so if you haven't voted, please do so. Okay. So about 41% of you are currently using NGINX in production and loving it. Fantastic. 31% perhaps are planning to use it in the future. 16%, 12% speak for themselves. Thank you very much for answering, folks. And with that being said, now I'd like to turn things over to my friend Matt Williams, evangelist at Datadog. Matt's appeared on a few of our webinars in the past. He's an entertaining and engaging panel member. Matt, thanks for joining today.
Hey, thanks so much. It's always fun to be here.
Good. Matt, I think you were going to take us out and maybe turn the driving over to Rick.
Yep. Oops, wrong button. Let's get rid of that.
Okay.
Let me hand over control to Rick, and so go for it.
All right, thanks. So welcome everyone. Control here. So I'm going to provide an overview of NGINX, what it is, what it does, and the differences between the open source and commercial versions. Then I'll get into some details of actually using NGINX. So I saw from the poll, a lot of you have used NGINX, some of you haven't yet. So I don't know, kind of what your knowledge is of the spread of NGINX out in the world. But these are some numbers that you can find if you go out and people who search this sort of thing, that it's now running in over 140 million sites, and over 42% of the top 10,000 busiest websites, and a very large number on Amazon Web Services as well. And just a small smattering of some of the enterprises that are using NGINX today. So NGINX Plus is the commercial version. It comes with support, and I'm going to go into a lot more details about that. But at a high level, you can think of it as a platform for doing high-performance application delivery. But what is NGINX itself? So the open source version has been around about 10 years now. It started out as a super fast web server to address to try to come up with a web server that can handle a lot of concurrent connections. And then over the years, it's grown into a load balancer and a cache. And I've just listed a few of the features here, including things like app acceleration, SSL offload, content-based routing, streaming media, etc. But it does a whole lot of stuff, and you're certainly welcome to go to nginx.com or nginx.org for the open source to see all the features that it can do. So I mentioned NGINX Plus, the commercial version. So so what is that? So NGINX is built on top of the open source. So the name NGINX Plus is pretty literal. It's NGINX open source plus some advanced features, as well as support. So it's a web server, so you can deliver your assets with unparalleled speed and efficiency. It's a load balancer, so you can optimize your apps, APIs, and services. It's a content cache. It can be either origin servers or for edge servers. It also can do streaming media. And then monitoring. Of course, monitoring is a big key topic today as we talk about Datadog, but we'll talk about ensuring the health, availability, and performance, and also how you can use DevOps-friendly tools to deal with that. And all of this in one package. So this is one piece of software that does all these things, and you can throw it on a bare metal server, in a virtual machine, in a cloud, in a container, wherever you want. So hopefully this diagram gives you a little better idea of where NGINX open source leaves off and NGINX Plus begins. So on the left, I have open source, and on the right, NGINX Plus. So a lot of the basic features you'll see on the left, such as routing, SSL, compression, etc., they're fully available in the open source. But when it comes to load balancing and caching, that's where we have the basic functionalities available in open source, but we've added some advanced features, such as session persistence and cache purge and so forth. And then as we move to the right, you'll see things like active health checks, activity monitoring, and so on. And that's are things that are only in the NGINX Plus, the commercial version. So I don't know if within this audience how many people are familiar with load balancing and why you do load balancing. So I want to just spend a minute talking about that for those of you who may actually not have a lot of experience in this area. Okay. So there are a number of reasons why you might need load balancing for your application. The two most basic and I think easiest to understand are high availability and scalability. So if you have only a single backend server on an application and it goes down, your whole application is down. So you want to have at least two servers to deal with that. And once you add that second server, you need some way of distributing the traffic across the backends, and that's where a load balancer comes in. Or if you find that that one server can't handle the load, then you need to add another server as well. And again, you need a load balancer to spread the load across the servers. But there are lots of other reasons you might want a load balancer. One key thing the load balancer provides is a stable endpoint for your clients. So your clients are completely unaware of what the backend looks like. They call one IP address, one port, one URL, and then the web server knows how to distribute those across the backend nodes. So the client has no idea if it's talking to one server or 100 servers. You can also rewrite URLs. So for example, you have thousands of clients out there all who have bookmarked a URL and you want to change that URL. You could have NGINX or any load balancer come in and take that URL and rewrite it to something that's the new URL without having to go back and change your clients. It also means you can split up your backends to handle different requests. So you may have started out with 2 servers with 3 applications. You can now put each application on their own server, or you can combine servers. All that flexibility is available because you've isolated the backend from the front end. So again, putting a load balancer in front of your backends gives you a whole lot of flexibility. Again, you can manipulate requests and responses, and there's a lot more that we could get into. But just to hopefully give you some idea of why people put load balancers in there. So let's talk a bit more about the benefits of NGINX Plus itself. So NGINX Plus is pure software, so there's no hardware involved here. And because it's software, you gain a tremendous amount of freedom over using a traditional hardware load balancer. And it's often deployed by the applications team, so they have direct control over the layer 7 application logic to best run their application rather than having to interface with the network team to try to get that stuff configured. And again, because it's software, as I said before, you can put it on a bare metal server, virtual machine, in the cloud, throw it in a Docker container, or any other containerized environment. It's also run on a commodity hardware, so it's a whole lot easier to scale up quickly and cost effectively. And you can also use DevOps tools very easily to modify, again, because it's just software. So you will find some other products in the space offering a virtual appliance form factor. And this is certainly more flexible than hardware, but it's not as flexible as pure software, because you can only run it in the virtual or cloud environments where it is supported, and you can't run it in a containerized environment at all. So we often hear from our customers how easy it is to configure NGINX. So that means your employees can spend less time tweaking configuration. And having the load balancer, the cache, and the web server all in one convenient software package, you now have only one tool to learn, one point of support for all these areas, rather than having to chain multiple solutions together. And finally, let me talk a little bit about value. So you'll find this to be a far more cost-effective solution. And for those using open source, you can now get a package and support a solution rather than having to maintain one yourself. Again, so your staff will now spend the things that are more important to them than having to maintain and support something like this. And because NGINX is famous for its performance, which is why you see the numbers that I showed earlier on the top websites, you can do more with less server resources, so you can save even more money that way. Let's talk a little bit about getting in actually and configuring and monitoring the actual features that you might want to use in NGINX or NGINX Plus. So I'm just going to really, as I focus in here, I've run a simple, very simple type application where I have a client talks to the load balancer and cache, which is load balancing some servers in the back end. So nothing terribly complicated here. In the real world, you often wind up with much more complicated multi-layer configurations, but we'll stick with something really simple for today. So let's start with load balancing. Okay. So I've just shown some of the features that are available in NGINX Plus. We recently introduced TCP load balancing to the product. So now not only does it do full HTTP, HTTPS load balancing, but it now does TCP as well. There's a lot of load balancing algorithms available, including least time, which we just recently introduced in our most recent release, that takes account of the response time from the back ends. So that joins the set we already had, which was round robin, least connections, hash, and IP hash as available algorithms. We also have multiple methods of session persistence. That's when you need to make sure that once a client gets sent to the back end, it always goes to the same back end because that back end node is where its state is. We've also had active health checks. So NGINX will continuously check the back end servers, and when it sees they're down, it will take them out of the load balancing rotation and then return them to the rotation when they become available again. And then NGINX has very powerful capabilities for routing requests based on content. So it can be URLs, it could be headers, anything else that you can see in the request. And that's one of the most popular use cases of NGINX. And there's lots of options for controlling traffic. You can do it based on the bandwidth, request rate, connections, and more. So when you're deploying modern web applications, whether it be in a virtual, cloud, or a container environment, you want to be able to take advantage of the flexibility of those environments to be able to scale applications up and down. So with NGINX, how do you go from the picture at the top here, where I have just one instance of a set of services, to the bottom one, where I now have scaled out, you'll see 2 on one, 3 on the other, and 2 on the other. So there's 2 features available in NGINX and NGINX Plus that can be used to easily scale up and down back-end servers that are being load balanced without having to reload the NGINX configuration file. The dynamic configuration API allows you to set an HTTP request to NGINX Plus, and you can add, remove, mark up, or mark down back-end servers. An alternate method we're seeing, which is becoming quite popular, is use DNS. So NGINX can be configured so that it determines the back-end nodes based on resolving a DNS name, and then it can periodically re-resolve that DNS name. So it may resolve it the first time and find there's 2 IPs associated with the domain name. It'll use those 2 for load balancing. It may, a few seconds later, can re-resolve it and may see there's now 10 nodes for that. So both of these options are really nice ways of integrating with orchestration and discovery tools, and which one works best for you, will depend on your particular application. Now let's move on a bit to content caching. So NGINX Plus is a full-featured caching server. It turns out NGINX open source is a very commonly used edge cache for CDNs, so it's quite well known for doing this. And you can have it obey cache headers, which would be the simplest thing. We can also override them, so you don't have to just obey whatever the developer said. You can actually manually control exactly how you want to cache. What we've added for caching in NGINX Plus is an API for allowing you to purge items from the cache. So you send in a request, an HTTP request to the API with a cache key, or a cache key and a wildcard, and remove that item or those sets of items. We find that very useful when people are doing dynamic content caching. So a little bit about how it works. So NGINX caches the objects to disk. So this is a persistent cache. If the machine goes down, when it comes back up, you'll still have your data there. The metadata is stored in memory. So basically, the table of contents is very quickly accessed. We take advantage of the file system cache to make that as efficient as possible. And for those of you who have done caching, you're well aware of the massive improvement you can get in performance. For those of you who haven't, I recommend you try it. And sometimes even things that you think that are too dynamic to cache, and I find this quite common, if you have a high traffic website, if you do what we call microcaching and cache something even for a very short time, it could be a second, it could be 5 seconds, you'll find that you've offloaded a tremendous amount of requests from the back-end servers, and your site's only out of date technically for, again, 1 second, 2 seconds, whatever it is. Your users are very unlikely to actually notice that the site is out of date, yet you may have just offloaded thousands of requests to your back end. And that's a case where you may want to be overriding the cache headers because the developer said it was too dynamic and has set it to no cache, and you can have NGINX override that and cache it for a second anyway. So since webinar is about Datadog, activity monitor is going to be a key issue for today, so let's talk about that for a bit. So NGINX Plus added a new status module. The open source has stats, a web server, so there's system-wide stats. The status module we've added with NGINX Plus returns a whole lot of data in JSON format, and these metrics are about load balancing. And we'll go into a bit more detail about exactly what's there. But again, it's an API request. You get the JSON back, which can be plugged into tools such as Datadog, which Matt will be demonstrating in a bit later, showing the plugin and how you can get that. We've delivered a dashboard, so a web page that periodically extracts the stats and displays them. And that's what you'll see here. I know this isn't very readable, but I'll show you, we'll see the actual page in action in a minute. But the upper part of this diagram is the page, and the bottom is just some raw JSON that you'll get on the request. Okay, so there's a little bigger picture here, and maybe hopefully somewhat readable. Again, we'll go on a live one in a bit, but you'll see some system-wide stats at the top, including things about connections and requests. Server zones, you can think of really as your applications, and you can define them however you want. And you'll see, again, connection, request data, bits and bytes sent, what kind of response codes came back, and so forth. Then upstreams, that's what we call the pool of backend servers. And you'll see in this case, I have a very simple upstream, which is one. Normally, you'd have multiples. But I was trying to squeeze this on one page, so I intentionally didn't have much data here. We also see the health of ones. You can see which ones are up, which ones are down. And then for caching, you'll see in the bottom here how much capacity you've allocated, how much you've used, what your hit rate is, and so forth. So let's actually look at some configuration files of something. So there's a lot of directives in NGINX, and anybody who's using it has probably seen the documentation on nginx.org. We've also added more high-level documentation on nginx.com, and I'm not even going to attempt to cover all the directives. NGINX does a lot for you. It turns out for what most people do, you can get by with a pretty subset of there, and most of the things you would want to tune. And we'll talk about tuning in a minute. The defaults work, probably 80% of the people never need to worry about most of these things. But I just want to show you, really basic config file. What you're seeing here is the sort of the master configuration file, which is from basically a default configuration file with not much in there. And you'll see at the top there, and we'll talk a little more about tuning the worker processes. So NGINX architecture is there's a master process and a set of workers. The typical best practice is to run one worker per CPU core. That can be adjusted, but that works best for most people. And that's what that worker processes auto tells NGINX to do. But I could have said 2 or 10, and it would open that many processes. These processes are single-threaded. They run in an event loop, and they're very efficient when it comes to memory and CPU. You'll see then error logging. You can decide what level, where you want error log, at what level you want to log to. And this can be done at any level. I have a system-wide, here I could have every application with their error log if I wanted. You see that events, worker connections, 1024. That's how many connections you want to allow a single worker to have. That comes with this in the default config here. That can usually be raised up higher. It really depends on your application. And you'll see the concept of blocks in an NGINX configuration. So you see where it says events, and you see the curly braces. And then to the right, you'll see HTTP and curly braces. Those are what we call configuration blocks. So the HTTP configuration block is for all your HTTP application logic. I haven't shown here the new TCP one, so there's also a stream block. But again, to keep this simple, similarly. So anything related to HTTP would go in this HTTP block. And one of the key features of NGINX config files is the include directive. You'll see a couple ones here, one at the top of the HTTP block and one at the bottom. That allows you to include other files. So rather than having to have one massively long configuration file, you can break your files up into small configuration files, which is a best practice. How granular you want to get is really up to you. I'll kind of show you how I've done it in a second here. And just a few things here. You'll see the log format. That's access logging. You can define a format. You give it a name. This one's called main. And there's a whole host of variables you can stick in there, so it's really customizable. And again, you can have one access log for your whole system, or every application could have its own access log. You'll see stuff for the, some headers like HT4 are in there, and the referral that we have in that log file. And then where to put the main access log. And then keep alive timeout. Again, these are some examples here. How long you, from a client, if you have client keep alives in action, how long do you let a keep alive be idle before you close it down? And that last line there tells it to include all the other configuration files in that directory. So that's the default directory for where you put config files. So this is a simple application. I have two pools of backend servers. One you'll see called website, one called store, again defined as upstreams. I've defined a cache at the top here. I've given how much space I want. I've also told it to do, if anything that isn't accessed for 600 seconds, delete it from the cache, no matter what its cache header says. Again, this is where you can override things. It's just an example there. And you can have any number of caches with different parameters. You'll see, I had mentioned before, when we talk about scaling, we can use our API to add and remove servers. So where we have this website one, you'll see there's one server there. I could make an HTTP request and add another one to that block. The second one, store, where I have server and I have a domain name, and that resolve directive tells NGINX to resolve that IP address into that domain name, into IP addresses, and then it will periodically keep checking there, and it will alter what's actually in that upstream group. Then the concept of a server, so that's really where your application lives, what port is listening on, what IP address. The domain name is here, and I've told it in this case. It's an application where I want everything HTTPS. So this is a very common use case of how do I redirect all HTTP to HTTPS, and here's how you do that. I've said listen on port 80, but no matter what you see, location / is basically saying what URLs do I process, / means everything. And then I say to basically do a redirect. Again, the same URL basically, but HTTPS instead. And it's going to go, again, this configuration file continues. I couldn't fit more on the one screen here. To another server block, and that's for my SSL here. So now you see I'm listening to port 443, and now I have a lot more directives here because this is actually where the work's happening. You see that status zone directive? That's key when we're doing stats. So that tells NGINX to collect stats for this server block, and that's what we'll see on the we would see on the status page, the server zones. And I actually forgot to mention on the last page that we had there was a zone directive there as well, which collects the stats and also acts for the dynamic configuration API. And then we'll see SSL certificate. I'm doing SSL decryption, so I tell it where the key and cert are. I want to do caching, so I'm pointing at that caching, the cache I defined on the previous page. These version and header, it turns on keep alives for the back end. So it tells NGINX, rather than opening new connections every time it talks to a backend server, open up a set of connections and reuse them. And then I've just shown some parameters here. I've kind of shown some common ones that people do override the defaults on. How long do you wait to get a connection to a backend server? The default 60 seconds, which is pretty long. I've set mine to 5 seconds. And the same with the read timeout. How long do you wait to get for the backend to start responding to you? 60 seconds is the default. Here I've made it 5. You could make it something else. And here I define my DNS server when I'm doing the resolution. I made localhost, and I've told it to keep things for 30 seconds. So every 30 seconds we resolve everything. And then I have 2 URLs I'm looking for. / means everything. And then /store says anything starting with store. So here I have my website, I have my store. So anything that goes to the store will get passed to that upstream group we saw on the previous page called store, and a website is the other upstream group for load balancing. And then one of the other features we've added in NGINX Plus, I mentioned a minute ago, is active health checks. So I've told in each case I want to be health checking those upstream groups. And And again, I could have just taken all the defaults, in which case it would just hit the index page, but I've told it to actually hit a specific page. I can also add other parameters for how often it does a request, how long it waits for a response, and so forth. Okay. And then I also have to configure the status configuration. Again, I've talked about the status API and the dashboard we have and so forth. That needs to be configured to tell NGINX to serve that and listen on that. And this is a very simple one where I've just said listen on port 8080. And if anyone makes a request to that without specifying something, it's going to bring up the status HTML page. That's the dashboard we delivered with the product, the one I showed you a screenshot of a minute ago. And then if it goes to /status, exactly /status, I want to return the API data, so the JSON response. And then lastly, to fill out my one, I want to do the dynamic configuration API. Again, that's the API that lets me add and remove servers. I've told NGINX to listen on 8001 for that, and to use the URL upstream _conf. It could be anything you want. And the upstream conf directly below that invokes that module and says this location is going to handle that module. In this case, I've told it, I want to restrict this to only requests from localhost and deny everything else. I could make those internal IPs. I could remove those and make it open to everything completely under you. I could blacklist IPs, whitelist IPs. All the standard NGINX features could be used in this location. So let's talk a little bit about tuning. That's too large of a topic for me to cover in much depth today, but I do want to talk briefly about the subject. Now, for most users, the default Linux and NGINX values will result in really good performance. But in those cases where you need to seek out additional performance, there are a number of options available for tuning both Linux and NGINX, but only a small subset are ones that you really need to consider under normal conditions. I recently wrote a blog post after talking with engineers about this subject. And in that blog post, which I recommend you reading if you're interested in the topic, of which features are the ones we recommend customers actually looking at. Beyond that, we'd really like to have you come back to our engineers who are the real experts in that, unless you are also real Linux and or NGINX experts to get into some of the more detailed ones. Let's talk about Linux, and you see I don't have a lot of things here. Again, most Linux operating systems have pretty good parameters, and for most users, you don't need to worry much about them. But here are just a few. So the backlog queue really relates to how connections are handled in queue. And if you have a really high rate of incoming connections and you're seeing uneven levels of performance, for example, if some connections appear to be stalling, then changing these settings can help to increase the number. For file descriptors, those are operating system resources. They're used to handle things like connections and open files. And NGINX can use up to 2 file descriptors per connection because it's proxying, so one from the client and one to the server side. Although this is lower if you're using keep alives, as I mentioned. If we're reusing connections, then it won't be quite as high. But if you have a large number of connections, you may find out that you're running out of file descriptors. You need to increase this, and you'll see an error in the Linux error logs, usually telling you that you ran out of file descriptors. In which case, you want to increase this one. And also, when NGINX is acting as a proxy, each connection to an upstream server uses a temporary, or we call ephemeral port. So if you're running out of ports, you'll also see this error in your error logs. If you see it, you're going to want to increase the port range. And that default time is how long does it wait for a port to be as idle before it reuses that. That's another thing. You reduce that to 5 or 10 seconds for most applications, and that'll free up ports more quickly. Let's move on to NGINX a bit. Again, NGINX has lots and lots of directives. I'm only showing a subset of directives here, and actually at the bottom just 2 sort of subject areas. So I'd mentioned before about the worker processes, and again, the best practice on this is the worker process is usually to set it to auto, to 1 core. But you may find, for example, you're doing a lot of SSL, which is very CPU intensive. You may want to increase that number. If you're actually not doing very much load at all and you have a very large server, you may find that running 1 per core is overkill. So you may want to specify it to run even less. The worker connections is how many connections can each worker handle. As I mentioned before, the default config I showed you was 1024. You can usually handle more than that, but it's no easy rule of thumb to tell you how much it can be. So the best way is to actually do some testing and increase that until you find NGINX has problems, and then back off a bit. But if you are processing a lot of connections, 1024 may cause the worker processes to stop processing connections, even though they have lots of CPU left. So it's a good one to look at. Otherwise, you're going to have an artificial ceiling on top of you. I'd mentioned key flags before. Key flags can have a pretty big impact on performance because you take all that CPU away from having to establish and tear down connections all the time. I'm not going to go into all these, but there's several. How many do you want to have? How many can they be idle for, and so forth. And then finally, well, not finally, there are a whole lot of limits you can do on the system. Again, I'm not going to get all the detail, but you can do, basically it's traffic shaping. So this is a matter of not making NGINX perform faster, but controlling what NGINX is doing. So by limiting connections or rate of request or bandwidth for clients, you can stop one client from overwhelming your system or taking too much resources. So it's more of a quality of service kind of thing. And anytime you're looking for maximum performance, you should look into content caching and compression. So content caching can get you just orders of magnitude, and it's 2 orders of magnitude improvement in performance. Again, in compression, if you use over small bandwidth connections, can also have a huge impact on performance. So now I actually want to show you our actual dashboard, and Matt has it set up on his demo system, so I was going to walk you through that, and then Matt can show you how much more fancy you get when you work with Datadog. So I'd shown you this before, but now it's a little bigger, so hopefully you can see it a little better. We see Matt has configured 2 server zones, so kind of think of that as applications. And you see how many requests are currently being processed, how many have been processed in total, the request rate that you're currently seeing there, and you'll see the responses, again, how many of 200, 300, 400s. Obviously 400s are errors, and you're seeing the red there flash up at certain times. You also see the bits and bytes that have been sent, both the average and the average as well, so you kind of get an idea of how it's performing. Can you scroll that up? Oh, there it goes, thank you. Yep. For the upstreams, I only had one, you remember mine. He's had a whole lot of upstreams. Again, you'll see for each upstream now the kind of stuff we saw for the whole application. How many requests are being processed and how many are coming back with errors, bytes sent, bytes received. And you'll see the server check and health monitors. So I've talked about active health checks, and that's what the health monitors are doing. And you'll see that things have passed, how many times they failed. You'll see if they're unhealthy or not. Right now, they're all sitting as passed. Server check is what I call passive health checks, and that's the health check may have said it was good, but NGINX couldn't connect to it, so it'll mark it down as well that way. So you get the status of all these ones here. And at the bottom, we should see the I'm scrolling stuff. So for caching, so we have one. So we only use 3% at this point. Let's see how much has been served, so forth. So this is the page that we deliver with NGINX Plus. The data, again, the raw data is available with the API, and that's where it can be plugged into like Datadog and to take this to a much more detailed level. So with that, that's the end of my presentation, and I'll hand it off to Matt. Thank you.
Awesome. All right, so just a little bit before I go too far into what I'm going to be talking about, a little bit about kind of the demo that we're showing here and the page that we're looking at. The page, well, let me scroll back up here. Basically, I've got 2 server zones. One of them is cached, where most of the content is actually being served from the cache, and then another version that's basically looking at the same servers, same upstream servers, but we're just caching less of that content. You're seeing a lot of errors that are popping up. Those I'm kind of forcing in there. Basically, here's the site that we're visiting. It's a bunch of photos that some of them are hosted on my local machine, and then some of them are actually coming from Flickr. Probably every one in every 20 visits to the site will randomly generate a 404, different 300 errors, different 400 errors, different 500 errors, and also the health check is being injected with a bunch of errors. Probably 1 in every 40 or 50 of those hits are creating errors, which is why we get something like this with lots of red lights happening. And normally you're not going to be injecting that into your servers, but it makes for lots of pretty lights in a demo. So let's get on to my little piece. So my name is Matt Williams. I'm the evangelist here at Datadog, and I'm going to be talking about monitoring and about Datadog. And so Datadog's a SaaS-based monitoring platform that can take, all the metrics provided by solutions like NGINX and NGINX Plus, as well as about 100 or so, 110 other solutions as well, and try to provide a lot of additional value on top of what they already provide. So based on that data that we've collected, basically taking it from NGINX and NGINX Plus of those status pages, we can create alerts or show dashboards with metrics that are correlated from other sources. So, you have your NGINX server that is generating a lot of metrics, but you also want to overlay on top of that metrics that may be about a GitHub commit or Jenkins deploys or your database environment, or some other business metric, how many sales coming out of maybe Salesforce, or contacts from Salesforce, or whatever it is. Bringing all this data, not just from one vendor, but from lots of different solutions, all into one place, and that's what we try to do really well. And ideally, we give you all the information you need to try to troubleshoot the problem. So why monitor? Why monitor in the first place? Well, we need to monitor to be able to see what's going on now. You want to see what the current performance is, and you want to see how this has improved over time. You want to see if you're doing better or you're doing worse. And if you're doing worse, well, when did the problem happen? How did it happen? What were the specific issues that caused the problem? And that way you can have a better idea of how to tackle the problem and solve the problem going forward. And of course, by having these metrics in place and a dashboard where you can look and go back in time, well, now you can experiment. We've seen that we've seen maybe couple of dozen different configuration options in an NGINX configuration file, and there are hundreds of those configuration options. And so tweaking them just right, well, it takes a lot of experimentation, a lot of the knowledge that you're going to find online on the web, but also experimentation on your part. And it's not really a good idea to experiment unless you have the numbers, unless you have recorded the metrics about how it's performed in the past and how it's performing now, so that if you experiment with a setting, you'll be able to see, did things improve or not? And just looking at how it's performing on the page, you looking at it, that doesn't give all the numbers. You really need to have all those metrics that look at all of the visits to be able to get a better understanding of how well it's performing. So we've been building Datadog for quite a while now, and we've helped a lot of customers with their monitoring needs as well. And in that time, we've seen, what are the most important metrics that our customers care about when it comes to NGINX, as well as other solutions. And we think we've got a good idea of what's the 5 key metrics that you really should be watching all the time. I think I've narrowed it down to 5. But actually, it's really hard whenever somebody asks, well, I'm brand new to NGINX, or I'm brand new to solution X. What do I monitor? What are the 4 metrics I need to monitor? 5 metrics, or 6 metrics, or 10? Well, it really depends. It depends so much on what your environment is like. It depends so much on what your business is like. So we can give you some ideas, some key metrics that you should look at, but it's really going to depend on your specific business needs as well. Some of these you might use, and then there might be some others that you find more important that we didn't include on our list. So the first one that I like to show is active connections, and this could be total as well as per upstream. Basically, this is looking at total number of connections coming in and that are being processed. And significant deviations in this can indicate a couple of different problems. First off, the server is struggling to process the requests. Well, that's a bad problem, and maybe you need to be adding additional servers to handle that load. There's also potentially indicates a problem in the load balancing method that you've configured. When you set up load balancing on NGINX, there's a number of options you can choose, whether it's least time for that first byte or round robin, and there's a bunch of others. And sometimes you might be choosing not the optimal method. And so you can play around with that. And that's the great thing about having these metrics. You can play around with these things and see, well, does it improve? Oh, okay, try something else. Let's watch it for a few hours or whatever your business intervals are to see if that improves over time. Drop connections is another really important one. Ideally, this should always be 0. It should always be a flat line. But if that number rises, especially if it rises significantly, you probably need to look for possible resource saturation. I have this environment that I'm running. I happen to be running on Docker on AWS. But at one point, I started adding containers, additional containers for my web server, my Upstream web servers. And first I added 50. I thought, oh, wow, that's cool. That's running really well. It's only using a small percentage of resources. I went up to 100. I was like, wow, that's cool. That's running 100, and everything's great. I thought, well, let me just try to blow it up. And I added another 500 containers on top that are all running. Basically, I did a Docker Compose scale the web to scale it up to 500. And all my connections started dropping as it wasn't basically the Docker environment was causing some issues. So drop connections, definitely a bad thing. And if you see that rise, again, look for possible resource saturation. Requests per second. This can alert you to spikes in incoming traffic or sudden drops. A spike, it could be good. Could be bad. It could mean you've been well, the term is no longer /dotted, but some number of something great has happened online that causes a lot of new traffic coming to your site, and maybe that's a good thing. But sudden drops, vertical drops, could be a bad thing. Could point to some sort of problem elsewhere in your environment further upstream. Now, when we're looking at requests per second, basically all requests are equal. So if the request to the front page is versus the request to the shopping cart where they finally press submit to charge the credit card, as far as the metrics are concerned, requests per second, both of those requests are equal. So just keep that in mind, but you generally want to watch for those spikes and especially watch for those drastic changes. And then there's, of course, all the error rates, 400 client errors or 500 server errors. But when you look at these numbers, don't just look at the raw numbers, but look at the number of errors divided by the total number of requests or responses. That way we're looking at overall percentage, not just raw numbers. And if we see those numbers climbing gradually, well, it's probably worth investigating. But as soon as we see a sharp increase, probably needs some urgent attention. Now, those NGINX or the error rates, if you're using the NGINX, the open source version, then you're going to be getting those from your logs. But if you're using NGINX Plus, you'll be able to see those error rates on the status page. There's also the request processing time. How long does it take each request to process? And as this number increases, it could point to an issue further upstream. So this is another one of those key metrics to take a look at. And then finally, I think this is finally, available servers per upstream. Now, often if you've got you've got an upstream, you've set up load balancing, but you only have one server, the health of that server is super important. You got to make sure that that server is always running. As soon as you add a second server, well, the health of that single server is a little bit less important because you've got that other server to handle the load in case something really bad happens on the first server. And as you increase those numbers of servers that are on that upstream configuration, then the health of that single server, or one or two or three, it becomes less and less important. And the number of healthy servers per upstream becomes really the important number. So I'm going to jump back to my little demo environment. And basically what I've got here is a single server, a single container, running my NGINX server as a load balancer and a cache. And then I've got some web servers, and I use Docker Compose to create the Docker machine and Docker Compose. And really, those are the reason why I went with the Docker route was that, well, this is a demo environment, and I wanted to be able to create that demo locally on my local machine, but then deploy it, depending on the demos I'm doing, whether it's for this one or doing something on Azure. I'd be able to just quickly create a Docker machine on Azure, on AWS, or on HP Cloud, or other places, and then deploy it. And you know, I finally deployed it to AWS last night, and it just worked beautifully. So it created a single load balancer cache, a single web server. I happen to be using for scaling up and for automatically registering all the machines. I happen to use console and registrar, but you could use the API, the configuration APIs that are part of NGINX as well. So let me just jump into that dashboard, and you know, we've already really seen most of what's here, but what you don't get in this environment is we don't really see much of the backstory. What happened yesterday? What happened the day before? And that's where something like a dashboard comes in really useful. So this is looking at basically that same information, and I can see drop connections over time. Okay, this is bad. I got to worry about what's going on here. I can see that's going really high. I can see the number of active connections, the requests per second. I can see upstream server errors, but I'm looking at upstream server errors, 500 errors, as a raw number, as well as a percentage of overall number of hits to the, or requests to the server. And so this becomes a much more important number versus this number. This is looking at the raw number. This is the percentage of all the requests that are out there. And so this is just basically looking at some of those metrics that I called out as being important ones to look at. And with Datadog, you could create this dashboard to be whatever you want. It probably would make sense for me to add, you know, the business metrics. What makes sense for my business, and add that here as well. Maybe overlay some of that data on top of each other. Maybe overlay the Docker events on top of this as well. And all this data is coming from this dashboard. This dashboard that comes from NGINX, and actually this is the raw version of that dashboard. We're looking at all the metrics. So that's my little piece, and at this point, I believe we're going to be switching over to some questions. So I'm going to hand it off back to, who am I handing it off to?
Alan. You're handing it off to Alan, I hope.
Yes, I am.
Okay.
There you go.
Hey, Matt, thank you. Matt, Rick, that was a great, I didn't realize just how technical that one was going to be. Matt, I think you could still handle your screen if we could just have the title slide or the last slide if you have anything with content information.
Okay.
Contact information. And we'll try to get to questions. As I said earlier, guys, we do have a questions section of the interface here in GoToWebinar. So feel free to write a question or two in, and we'll have Rick and Matt jump on that. But before we do, just wanted to quickly say, guys, what a great webinar presentation that was. It was very, very technical, and you know, our audience here at DevOps.com tends to be very technical. So I thought it was great having both of you do demos. Fantastic. Let's see if we can get some questions out of the way. So our first question, I guess, would be for Rick, because it's strictly on NGINX. But in NGINX, is NGINX Server vulnerable to Ghost, Poodle, or some of the other latest, greatest SSL security vulnerabilities? Well, let's answer that first.
Yeah, so I'm referring to all of them. So NGINX uses OpenSSL. So, which we dynamically link to. So if it's an OpenSSL attack, it's not something that we're vulnerable to directly. We're indirectly vulnerable via OpenSSL. So for example, when Heartbleed came out, customers had to upgrade their OpenSSL. They didn't need to do anything with NGINX. So in general, the OpenSSL attacks are, SSL attacks are OpenSSL issues, not NGINX issues directly.
Sure. Rick, how frequently are the security patches released for NGINX?
So regular patches, so NGINX open source is generally released a new version about once a month. NGINX Plus is every 3 to 4 months. When if any security issue comes up, then that's released basically as soon as we have it fixed. So it's not scheduled. That just happens as soon as we have it fixed. We immediately release it. And now NGINX.org, you'll see we on the mailing list and so forth. We announce that if there's been a security issue, it'll be immediately released.
Yep. Let me quickly also address the issue of OpenSSL vulnerabilities, such as Heartbleed and Ghost and Poodle and some of these others that we've seen. You know, my background is in security, guys, and you got to understand, you know, so much of our software today, rather than being written by hand from scratch, is made up of components that are pre-existing, and the overwhelming majority of those components are open source, such as OpenSSL. And I have friends of mine at a company called Sonatype. They probably run the largest open source repository out there, and they've done a lot of research on this. It's very, very hard for a company like an NGINX, you know, that has packages, right? They have a web server here, and there's multiple packages and distros in there, and they're not going to go out and actually patch OpenSSL. We need the OpenSSL community to actually usually do those patches, because could you imagine a world where, well, NGINX has patched OpenSSL, but some other server or OS hasn't, and it becomes real chaos. So the place to patch OpenSSL is in OpenSSL. And you know, it's something we all need to be worried about as more and more of our open source, as more and more of our tools, you know, rely on open source components and or you know, things such as OpenSSL. Anyway, moving on. Has NGINX has NGINX live loaded feature at client side? If any changes at code level, then client should get latest changes. Does NGINX have a live loading feature maybe? Is that what they're asking? I'm sorry.
Yeah, I'm not sure what they're referring to. We don't have anything that we're doing on the client side. NGINX is strictly server side. So anything that would be client side we have to come through NGINX to a back end that could reply to them, but NGINX itself does not push anything to clients.
You know what? And that was asked by someone last name Patel. Mr. Patel, if you can re-ask that question. I got a feeling we messed it up perhaps in,
I think so.
the way it was written.
But
I apologize.
But the NGINX, Rick, how about if the configuration files change on NGINX? Will the NGINX server restart?
So for changing configuration for everything, so the API I talked about for upstream servers, the backend group that we have an API for. Everything else you change the config file and you do a config reload. What NGINX does then is it fires up a second set of worker processes. So all the new requests, all new connections are handled by the new workers using the new configuration. All the in-flight requests are worked on the old workers, effectively drained off, and then when all their work's done, they terminate themselves. So it's a seamless upgrade. You don't lose any requests or connections. That's how the upgrade process works if you're doing anything with the config files.
Cool.
Okay, so it seems that we're talking about an auto refresh on at client side.
Yeah, so we don't, again, NGINX doesn't do, we take requests from the client, so we don't do anything that would refresh a client. That would be something that the application would want to do. Again, through NGINX, but it wouldn't come from NGINX directly.
Okay, if we messed that question up, I apologize. Matt, it looks like we have a question here for you from Matt. That's how I knew.
Yes.
That was just a little hint.
Amazing.
Datadog comes with other metrics for NGINX that you didn't cover. Can you make a brief mention of what NGINX.NET reading, NGINX.NET waiting, and NGINX.NET writing are measuring?
Yeah. So NGINX waiting or NGINX.NET.waiting basically are the idle connections before so there's a request comes in and as soon as it's NGINX says, okay, yes, I'm going to handle that, then it goes into that waiting group. And then the reading, NGINX.NET.reading is basically the next step along, where it's reading the request and then writing, it's actually writing out the request. So it's actually sending it back down to the client. It's my understanding of those three metrics. Is that correct, Rick? Does that sound right?
That sounds right. I have to go back and look to be 100% certain, but that sounds right.
Yeah.
Matt, I should mention, I always love enjoying your demos of the Datadog interface. I wish I had something like that when I had to do that kind of stuff for a living. They did a good job
cool
on the interface there. Okay, Mr. Patel has kind of, I think, rephrased the question here, and Rick, we're going to throw it back at you. He wants to know, is there grunt integration for NGINX?
Not from us. I'm not an expert on grunt, but there's nothing we've done. So I should look into.
Okay.
Yeah, I mean, NGINX is really on the server side rather than anything on the client side. If you're doing client-side development, yeah, you're going to be, as soon as you make some code changes on your local HTML or PHP or whatever your server programming language is, you make that change, and then there's going to be some other tool, whether using grunt or code something, or other tools, grunt, gulp, whatever that is, and those tools are going to do a refresh of the client browser, which has nothing to do. I mean, yeah, I guess it has something to do with the server, but really all you're doing is refreshing the browser to look at the new version of that page. So those are all client-side activities, and not so much about server side. If you're making changes on a server and you want all the clients in the world to see the updates to those updates, then it's really up to you to build your applications with some of the kind of Ajax-y kind of ideas, so that your client looks for those updated changes and requests them, makes those requests again from the client.
Excellent. Next question from Julian. How does N Plus and NGINX AWS AMI differ? What are the benefits of the AWS AMI?
So the AWS AMI for NGINX Plus is no different than our regular one. It's just it's for convenience that it's so you can just grab the AMI. You don't have to do it. It comes effectively pre-installed with NGINX Plus, but there's nothing different from that, the NGINX Plus AMI in Amazon, than if you come to us and purchase NGINX Plus. It's the same binary.
Guys, we only have time for another question or two, so let me get to them. Does NGINX caching only work into disk mode, or can you cache to RAM only, or potentially use memory map files?
So you can, from an NGINX perspective, it always wants to write to disk, but if you mount something like tempfs that looks like a disk to NGINX, then it will cache to memory. But it has to look like a file system to NGINX, but there are definitely RAM file systems you can set up to do that.
Excellent. And then last question, because we're already late. Can Rick review what types of session handling is in NGINX Plus versus NGINX? Yeah,
so NGINX open source, the core doesn't come with any session persistence ability at all. There is a third-party module, which I'm aware of. I don't know all the details. NGINX Plus comes with the options of having NGINX set a cookie. You can have NGINX monitor a backend cookie, or actually you can monitor backend headers, and then you can also have it when the client comes in, you can actually look for the client to pass in a cookie or pass in the URL. So there's a very simple ways of basically monitor a cookie or set a cookie, or you can customize it a little more. For example, to say, check the cookie. If it's not the cookie, then check the URL.
Excellent. I think that's it for our questions, and it's a lucky thing at that because it is 2 minutes after the hour. Again, Matt, Rick, thank you for doing a terrific job today on our webinar. Thanks to Datadog for once again sponsoring a fantastic webinar here on DevOps.com. And most of all, thank you to all of you who've stayed here till the end and may have joined in, or maybe you're listening to this taped and not live. Thank you for joining us. The tape. I don't have tape anymore.
Tape?
What am I
sending out
saying?
tapes to everyone?
Yeah,
Awesome.
exactly. We'll play it on an 8-track or a cassette. But no, the recording of this webinar and the slides will be available on DevOps.com within 24 to 48 hours. Again, Matt, Rick, thank you very much. Thank you to our audience. This is Alan Schimmel for DevOps.com, and thank you for joining us.